There are many functions in ParaView Python that let you pass information down the pipeline browser and then use that information for visualization. So these are some of the functions that I use all the time. And getActiveCamera returns the active camera for the current view. And then getActiveView returns the active view. So these are quite similar to each other, but there are some differences between them. So we're just going to play with these in the next few slides. Let's load the same sign envelope dataset, and let's draw an isosurface, let's say at the value of density 0.15. So I'm going to start ParaView. I will navigate to the data directory. The file is signenvelope.nc. It's an SCDF reader. So hit apply, and now apply a contour filter. So we are drawing an isosurface of density, and the value of density is 0.15. I'm going to say apply. Let me hide the outline from the first object. So here we're looking at the isosurface of density. Now let's open the Python shell in the GUI and type these commands. You can also copy and paste these commands from a file called clipboard.txt inside the zip download. So I'll go back to ParaView. I will open the Python shell. And then here, actually, let me call this not by density, but by a solid color. And then I will go to Edit Color Map, and I'll just pick up a bright color, for example, yellow. So here I click on the Python shell, and inside the Python shell, I'm going to run the following commands. So first, I'm going to run the getActiveView function. So the active view will be written into the variable called v1, and it has a number of attributes. So if you type dir v1, you'll see it has a number of attributes. One of these attributes is camera focal point. So let me print it. I can simply say print v1.camera focal point. So it is 49.5 in all three dimensions. So this is the point we're looking at. This is the focal point, right? So the central point in our visualization. And let me also print the center of rotation. So I'm going to say print v1 center of rotation. And it's also the same value, right, in x, y, and z. So this is very important that the focal point is the same as the center of rotation, because next we're going to spin this data set, and we want to make sure that it is spinning around the central point so that the entire visualization doesn't go out of view very quickly. Now let's set the number of frames to 360. So I'm going to say n frames is equal to 360. Now let's run another function called getActiveCamera. And we'll assign its output to the camera object. And then let me copy and paste the following script. So this script for I in range of n frames. So n frames is equal to 360. That means that I runs from 0 to 359. We're printing additional operation, the current camera position. And then we rotate our visualization by 1 degree around the vertical axis. So essentially, what we're doing is we're moving the camera around the visualized object by 1 degree on a circular path. So 360 degrees divided by 360, so that it gives you 1 degree. And then we save the screenshot. The screenshot will be saved into desktop folder, into the file frame. Then there are 4 digits, and I will go into these digits, .png. So let me hit enter, and it will run. It is running, even though it's not refreshing in the GUI, but you can see the spinning wheel. And if I go to the terminal and type the desktop folder ls frame, you'll see that it is actually creating this frame. So out of 360, it created 140. If I do it again, you see that it created 200. Let's just wait for it to finish. And here we go. We just created 360 frames. And you can see here's the output from all those print statements. We're printing the camera position. So now let's go to the terminal. Here we have 360 files. And I'm going to run the following ffmpeg command to merge this into a movie. The movie I'll be creating at 30 frames per second. And the command, let me just paste it. Here's the command. So 30 frames per second. The input files are frame and then 4digits.png. And then the output file was going to be called spin.mpeg4. So let me run it. It's merging the frames, going to 360 frames. And it finished, so let me do ls-l on the file. The file is 1.2 megabytes, so you can actually fit this entire movie onto a floppy drive from the 1980s. So let me open the file. And it shows on a different window right here. And let me play it back. So as you can see, we got a nice movie where we're spinning the visualization around the vertical axis in 360 steps. A really nice visualization is only 1.2 megabytes large. All right, let me close that. Let me go back to the slides. So now let me show you another camera animation. I'm going to fly 2/3 of the way towards the focal point. Let's start from the current camera position, and then I'm going to continue typing commands inside the Python shell. I'm going to type the following command. I save the current camera position to the variable initial camera position. And so if you print this, this is actually going to be a tuple. There are three numbers. So let me print this. There are three numbers, x, y, and z, showing the current camera position. And then let's set the number of frames to 100. So we're going to say n frames is equal to 100. And then let me copy and paste the following code where we're going through all frames. So here I goes from 0 to 99. And then we have a coefficient. So this is a floating number that runs from 0 to 2/3. And then we're printing the coefficient and the camera position. And then we're setting the camera position to this interpolated value between the initial camera position and the focal point. So where it says here we have camera focal point, here we have initial camera position, and we're just interpolating between them. So that initially at iteration 0, the camera position is going to be in the initial camera position. And at loop iteration 99, the value of camera position is going to be 2/3 of the way between the initial camera position and the camera focal point. So we are setting the camera position, and then we're saving the screenshot into a file called out and then 4digits.png. So let me hit enter. It will run. It is currently running. You can see the spinning wheel. If I go to the shell and search for out files, you can see that it's running. It's almost finished actually. 70. It created 70 images, and now it finished in the GUI. So it printed all that output. So let me go back to the shell, to the terminal. Let me paste another ffmpeg command. I'm going to be creating a movie called approach.mpeg4 at 30 frames per second. And this movie is going to be created from these out.png files. So because we have 100 files and 30 frames per second, the movie will run for 3.3 seconds. So let me create the movie. Here it is. And then if I do ls-l, you see that the movie is 400 kilobytes, so it is tiny. Let me play it. I'm going to say open approach.mpeg4. And here's my movie. So let's just play it back. And as you can see, we're flying 2/3 of the way towards the focal point in 100 frames. And the movie is 3.3 seconds long. Now here's an exercise that we'll do in the Zoom session. Write and run and complete off-screen script. So please study this in the slides and then try to do this on your own. And if you cannot, then we'll do this together in the interactive Zoom session. Extracting data from VTK objects. So all variables that you can find inside a ParaView Python script, they're actually VTK objects. And you can extract data from them. This shows you an example. There is a data set called stval.nc inside the same data directory. And this script just shows you how you can actually extract data and convert this data into NumPy arrays or some other data structures.